Today we are going to be discussing transistors. Transistors are an active component. There are two primary types of transistor: the bipolar junction transistor also known as the BJT, and the field effect transistor. Also known as a FET. In some cases, the field effect transistor generates a lot of heat, so some people jokingly refer to a FET as a fire-emitting transistor. Hopefully that doesn't occur in your careers. But anyway, bipolar BJTs work with current, whereas field effect with voltage. A transistor has three connectors, three connections. For bipolar junction, they are the collector, the base, and the emitter. For a FET, they are the source, gate, and drain. Now, why they are called active components is that they can amplify signals if used properly. The symbols for the BJT is like so, and the FET is like so. They have in the data sheets for these components a characteristic known as the beta, which is the amplification ratio, basically. Now, use the BJT as an example for that. So you have, let me go ahead and just use the so you have a small current put into the base increases the amount of current that can go through the collector. IC equals beta times IB. IB may be 100, it might be 50, it might be, you know, any kind of number. And then IE, the current coming out of the emitter, is IB plus IC. So a small increase of the current flowing through from the base to the emitter will cause a larger signal coming through the collector, a larger current coming through the collector to the emitter. Now that this is used in a common circuit. This is a common emitter single stage inverting amplifier. The signal out is an amplified but inverted signal matching the signal in, just amplified. So a small signal in here, a small AC signal in here, will have a larger signal going out. But it will be out of phase by 180 degrees. The values of these four resistors determine the characteristics of the amplifier along with the characteristics of the transistor. And this capacitor here is a filter that filters out any DC component going into the transistor.
What did you say that
What? Oh, let me just write it out here. Single stage common emitter inverting amplifier. It is called a common emitter because the output, the load that you would put across, come on, load shares a common ground, the ground is common with the emitter and the ground, and the load. The ground is common between the two. There's also common collector amplifiers and all that sort of thing. But the common emitter inverting amplifier is one of the more common types of amplifiers that you see. But that's one way they can, transistors can be used as an amplifier. Transistors can also be used as switches. These are typically FETs, like, for example, a FET a FET used in this configuration is an inverting switch. You apply a voltage to the in line, it turns on this transistor, which creates a short circuit to ground from power. So a high level here will short the output to ground, making the output low. By the same token, if you have the low here, the power will go out the outline, making the output high. The transistor is acting like a switch, switching off or on the output signal. Now we'll get into after the midterm how these FETs can be grouped together to make logic gates for digital logic circuits. They act as switches in different combinations and configurations to make the digital logic that is used in your cell phones, your calculators, your laptops, all those fun things that are digital electronics. The use of transistors as a switch is very important. Of course, this is only scratching the surface of what transistors can do. There are whole books or semester-long classes just on transistors alone. In Electronics 1, you cover the inverting amplifier I just showed you and how to tune it and all that sort of stuff. The Electronics 2, I believe, gets into analyzing such circuits so that you can determine the bandwidth and what frequencies a inverter can, inverting amplifier or an amplifier can process. But let's see here. Oh, we can go back to the first page. There are two types of BJT transistors, NPN and PNP. FETs have P-channel and N-channel. The two types, so that's 4 types of transistors in all. I'm sorry? What is the 4 type? NPN, PNP for BJT transistors, and P-channel and N-channel for field effect transistors. So any questions about transistors that doesn't go beyond the scope of this class? Like I said, they're very versatile and simple yet complex use cases for transistors. So, like I said, entire books are dedicated to the physics of how they work, how and when to use different types of transistors, different manufacturing techniques. What you might see is a MOSFET, which is a metal oxide silicon field effect transistor. Which just describes what manufacturing technique was used for it, but it's still basically a field effect transistor. Yeah, I was thinking this might take a little bit longer than it did. So I guess we can call that a day. Monday, we're going to just do a review session for the midterm, which will be on Wednesday. In person, open note, on paper. The midterm is Wednesday, which is, I believe, the 1st. So be here. I will not be able to have you take makeup for the midterm because midterm grades are due Monday at 5, the following Monday at 5. So there's no time to make up the midterms. So be here on Wednesday. Have a good day.